So today I've been given a vehicle which has a fault, but I've not been told what the fault is. It's not clear what the fault is. I have to find the fault and fix it. So my first step is to run the engine, and then of course I can hear the engine is not misfiring. I check the fuel pressure. Fuel pressure is normal at 200 kPa. It doesn't fall even with stabbing the throttle. The kick down. So now I bring out the diagnostic tool, and I have a basic list of data that I want to look at, especially things to do with the oxygen sensor, the short-term fuel trim and the long-term fuel trim, as well as the temperature and the engine speed. Those are going to be of interest to me. Meanwhile, I'm running the engine. I let the engine continue to run because I want it to warm up. And I have a preliminary look at the data. I can see the engine is still running. The engine computer is still running the engine in open loop. But I'm revving the engine up to rule out the oxygen sensor being faulty. Oxygen sensor data is in what's that color, green. You can see there's oxygen sensor response from the signal, from the graph, from the oxygen sensor output voltage. So the engine is running rich now, as shown by the 0.8 volts from the oxygen sensor, which I have established is working, because when you start the throttle it falls all the way down to 0.1. The engine momentarily runs clean. Otherwise, when left to idle at cold temperatures, at low temperatures, the engine is in running in rich condition. So I rev the engine up because I want the temperature to increase, so that the engine temperature to increase, so that the engine computer can allow the engine to go into closed loop. So the engine computer is warming up. No, the engine is warming up, and I'm watching the engine computer data. Yeah, at this point, the short-term fuel trim is responding. So that means the engine computer has put the engine into closed loop operation. And at this point, around 92 degrees, I'm expecting the fans to come on, the cooling fans to come on, but they don't. Right now I'm revving the engine up and down to try to prompt the cooling fan to come on, to get the engine computer to command the fan, and also at the same time to observe oxygen sensor response. I do not see the fan turning on and the engine is overheating, so I turned the engine off. I did observe that the oxygen sensor was still responsive even when the engine is hot. So I don't believe this is this fault on the car, unknown fault on the car, has anything to do with the oxygen sensor. But I'm now beginning to get suspicious of the cooling fan operation, because for a moment there the engine temperature went into the red zone, which meant the engine was overheating, and the engine cooling fan did not come on. So it is time to examine the wiring diagram and establish some basic facts. My first step is to check out the fuse for the engine cooling fan feed. For the fan to run, it will need battery voltage. My checks with the multimeter reveal that the fuse is intact. Although for a moment there, when I was double checking, I was on the wrong fuse. I was on fuse 16. The right fuse is fuse 15, which is what I'm double checking right now. I checked it earlier. I'm sure you saw that. So I'm double checking it. As far as I can see, the fuse is intact and working as it should. So this fan should be getting power if commanded by the engine control module through the fan relay. So now I need to take a closer look at the wiring diagram, because my next step will be doing electrical checks at the relay, the cooling fan relay, and that will tell me, will give me a good picture of the wiring upstream of the relay. By upstream, I mean from the power side of the relay. My plan is to check that the power side is working as it should, and then concentrate on the control side. Observing the wiring schematics and making notes takes some time. So what looks like a pause to you here is me digesting this wiring diagram, especially with regards to the cooling fan. I can see I have relay K1, which is in control, which is used to control the fan, but it is commanded by the engine computer to do that job. So now I want to eliminate parts of the circuits that are working and those that are not. So I do my testing at the cooling fan relay. Yeah, looks like the load side, at least the upstream side that full-time battery voltage is working as it should. But now I want to be sure that the control side is working as it should. I go back to the diagnostic tool and notice that there is now a code in memory for the oxygen sensor. Such codes can throw you off the track. I've seen the cooling fan fail to come on when the temperature was high enough for this fan to be turned on, and it didn't. So for now, I'll ignore the oxygen sensor the computer to need to turn on the relay. And at the same time, I'll be observing the relay terminals, especially the control side. So using the engine RPM just to make warm up the engine faster. At about 90 degrees now, and beyond 90 degrees, between 90 and 95 usually is where I should see fan chemical happening. The electrical checks I'm doing with the multimeter now, I have to check that the fan is being controlled, and I don't see that. And the temperature gauge has gone into the red zone, meaning the engine is overheating. I don't see the fan being monitored by the engine computer, at least at the relay. I don't see that happening. So now I need to turn off the engine to stop it overheating, because now I don't have good fan operation after the no fan operation. So as I'm talking about my next step, I try the engine one last time to see if the fan will come on. It doesn't. So now I switch off the engine and then return the key to the key on engine off position, and then go to the diagnostic tool and try to operate the fan through commands. Doesn't look like this cooling fan is working. Even as I'm commanding the relay, the associated relay to operate. So it looks like the relay is not operating, and that's why the fan is not operating. So the computer is unable to command the relay, is unable to control the relay to command the fan to come on. So thinking about my next step, I've seen that the relay is not being commanded at the relay terminals, but now I need to be sure that I don't have a broken, an open relay command wire from the computer. So I need to go testing the terminal at the engine computer where I expect the output for the engine coolant fan relay command. And that's pin 2. So I need to run the engine again. I'm already in the red zone, so I shouldn't be seeing battery voltage at that pin, because the computer should be commanding the relay to turn the fan on, and to do that, the computer needs to ground that wire. Instead, I'm seeing 12 volts, which are coming through the control side of the relay, the control coil of the relay. That tells me the control coil is okay, the wiring is fine, at least up to the computer. I go back to look for fault codes. I'm seeing even more fault codes now, but I ignore them. Of course, there are codes now for the fan rationality check, which figures, because even the computer has realized now that it's commanding the fan on, but the fan is not turning on. I ignore all the other codes that I found, because remember, to to test at the computer, I had to use the breakout box, and while connecting it, yeah, I may have caused those other codes. So that's why I ignored them and erased them. So now even the engine computer is realizing the fan is not doing what it is commanding it to do. So there must be an internal problem with the engine computer with regards to control of the cooling fan relay. So I change the computer, I replace it with a new one, and after that I need to program the computer, and that's my next step. Program the engine control module. Having done that, you can hear the fuel pump prime, so which means the engine computer is now functional. And I go for the actuator test. And now when I command the fan to turn on, the fan operates. So right there is I have fixed the vehicle, but I need to prove it. I want to run the engine once again and see if the fan will come on without intervening, without me commanding it from the engine control mode. I want the engine control mode to do that by itself when the engine temperature reaches the right pressure. Meanwhile, all the functions are out in memory, so I erase those. Yeah, you can hear the fan has come on, and you can see the voltage went down at the relay control wire, and then went up when the computer was satisfied with the engine temperature lowering. So now I don't have any fault code. The engine is running fine. The fan is coming on when it should. Engine is not overheating anymore. Yeah, so basically I'm done at this stage. I have to return equipment or recover equipment from the vehicle. I have to return it to storage. And I do one final check that I don't have fault code, but I see an oxygen sensor fault popping up. I ignore that because it's in memory, and I don't want it to confuse me. I'm sure I don't really have an oxygen sensor issue at this point. So now it is time to write up the report of my diagnosis and findings. So briefly to recap, initially there didn't look like there was a problem. The engine ran well, no misfires or anything, cranked and ran well, but I figured the problem must be when the engine is warm. I was expecting either some kind of misfiring to start happening, engine misfiring to start happening when the engine warmed up, or as it turned out, engine overheating because the fan wouldn't come on, or some other problem related to some other problem that happens when the engine warms up. One needs to be aware of, needs to understand the system well enough to figure out what the potential problems could be. So yeah, I've finished fixing the vehicle, and it's time to return the vehicle to the owner. The vehicle is now fixed.